Hello everyone, welcome back to Calculus BC. We're now in lesson 34 where we're learning more integration techniques. In this lesson, we're going to talk about integration by partial fractions, which is also known as partial decomposition. Before I get to that actual piece of our lesson, I want to say very quickly that you have to look at the degree of your numerator and the degree of your denominator because, depending on what that is what method you use. So we've actually already talked about long division in the previous lesson. But if your degree of your numerator is equal to the degree of your denominator, you will use long division. If the degree of your numerator is greater than the degree of your denominator, you're also going to use long division. So these two questions will be using long division. But the video that we're talking about today is, well, what happens when the degree of your denominator is greater than the degree of your numerator? You will use what we call partial fractions. So I'm going to do an example for you guys here in a second. There's two methods that you can use, and so this video will be on the very first one that you're going to see right here. But for this example that you see that's already written out for you guys, this is just a really nice way of doing the problem. You're going to see that we are integrating a rational function, which is very important. You need a rational function to do this, and your degree of your denominator is actually greater than the degree of your numerator. Is this always the case? The answer is no. The answer is no. If I ask you guys to integrate, so just really quickly, I say that all the time. So if I ask you guys to integrate this function, then this is a u sub problem that ends up being a natural log. So you want to try other stuff, u sub, natural logs, before you get to partial decomposition. So you can see that if I make u equal to x squared minus 1, then my derivative is going to be 2x squared minus x. The derivative is going to be 2x minus 1 dx, and so you have a natural log problem. Well, let's say that doesn't work. Let's say this is not what we have. Then you can say, well, let's factor the bottom, and then you're going to be able to create two fractions that when we add them together, we're going to get this fraction back. And so we're going to multiply everything here by x minus 3x plus 2, which gives you this step right here. You're going to say, okay, well, when x equals negative 2, that's going to cancel this guy out right here, and then you're going to be able to easily solve for b. Then once you've solved for b, then you can now say, well, let's look at what happens when x is equal to 3. That's going to cancel it out. You're going to plug in 3 here and here. You're going to find out what a is. You're going to use the equations for a and b. We're going to integrate them, and again, most likely they're going to be natural logs. So that's a very brief introduction to how to do questions. So let's actually start them. Let's do a couple problems together. So for question number 3, we're going to say, well, if I try u sub, it'd be 2x minus 1. Well, that's not x minus 1. So what we're going to do is we're going to do a over, so first thing we got is we got to factor. So you always want to factor your denominator. And so you're going to get x, 3, 2, negative, positive. And so one of our factors is x minus 3, so we're going to plug that underneath of a, and it doesn't matter which one goes underneath a and which one goes underneath b. And we're going to do plus, and then we're going to do x plus 2. And I'm going to keep the integrity of the problem alive here by just writing the dx. So we got to figure out what a and what b is, that if we were to add these fractions together, we would get, and simplify the numerator, we would get x plus 7. X plus 7. So the first thing we're going to do is we're going to multiply, and let me actually write it out like this for us. So let's lose the integration for 1 second because this is our first example. So let me just go ahead and go basic here and write this all out one more time. So I apologize for the time here, and I want to multiply every single piece. So all of these pieces by x minus 3, x plus 2. I want to multiply this piece, and this piece. So you guys can clearly see that these are going to cancel out, right? These are going to cancel out. So if I multiply this by this, I'm just going to be left with x plus 7. The x minus 3s are going to cancel out, so I'm going to be left with a times x plus 2. And then this one's easy to show that if I multiply this by this right here, this is going to cancel, and we left with b times x minus 3. So that's kind of the idea of where we're starting with this. And so I'm going to go ahead and write this out again as x plus 7. So all the stuff that I'm doing right now, all the stuff that I'm doing in this particular right here is all going to be just extra work. It's just going to be practice. It's going to be our side work, if you will. We're not doing any true calculus right now. So if I make x equal to negative 2, if I make x equal to negative 2, then I'm going to be left with negative 2 plus 7 on the left-hand side. I'm going to do a negative 2 plus 2 b negative 2 minus 3. The reason I chose negative 2 is because, again, I want one of these to go away, right? I've got two unknowns with one equation, because x can be anything. We can make x anything. So let's make x equal to negative 2. Well, that's going to eliminate this term, right? This term is going to completely go away. So I'm going to be left with 5 is equal to b times negative 5. So I know that b is actually going to be equal to negative 1. So I can go ahead and replace b up here with negative 1. Or I could just do minus 1 over x plus 2. And then I'm going to repeat the process, ladies and gentlemen. I'm going to go do the same thing again. And the only difference is that for this one, I'm now going to make x equal to 3. So let's do that. X equals 3. Well, then I'm going to do 3 plus 7 is 10. 3 plus 5 is 2. 3 minus 3 is 0. This is going to cancel out. I'm left with 10 is equal to a times 5, or 5a equals 10. So a in this case is going to be equal to 2. So I can go ahead and erase our a, and I can go ahead and create this as a 2. And so let me pause. And so now, guys, these two functions are equal to each other. This function right here and this right here is equal to each other. I'm not going to do it in this video, but if you were to add these fractions together and simplify the numerator, you are going to get x plus 7. So what we're going to end up doing is we're going to take these individual fractions and integrate them independently of each other. And that's all that you do for partial decomposition. So you're going to use u sub, right? We can pull the 2 out if we want to, but we're going to make u equal to x minus 3, and then our du is going to be equal to 1 dx. Over here, u is going to be equal to x plus 7, or sorry, 2. Du is going to be equal to 1 dx. Be careful about these numbers. Sometimes students mess this up. So, make sure that you guys pull out constants if you need to. And so our final thing here is going to be 2 integration of 1 over u du. I'm going to go ahead and pull the negative out. So minus the integration of 1 over u du. And you guys know as well as I know that these are going to be natural logs. So we're going to be left with u natural log of the absolute value. Please be careful with the absolute value of u minus 1 natural log of the absolute value of u plus c. And so our final answer that we're going to have for these particular problems is going to be 2 natural log of the absolute value of x minus 3. And it's going to be minus the natural log of this one, which is going to be the absolute value of x plus 2 plus c. So this is going to be how you integrate that problem. Okay, so let's go ahead and try to do one more example for this. So we're looking at the integration of number 4 here. Again, if we try to use u sub in the denominator, our derivative would be 4x minus 7. We have a 4x plus 3. So just like in the previous example, the first thing we want to do is we want to factor the denominator. And when we do that, we get 2x minus 1 times x minus 3. So I know that this integral is going to be equal to some value a over one of the factors, and then it's going to be b over one of the other factors, which is going to be dx. So I'm going to do some liberties here. I'm going to go ahead and multiply everything by 2x minus 1 and x minus 3. So in this left hand side right here, again, I'm getting rid of the integral and the dx, so I'm just looking at the fractions right now. So the left hand side would be 4x plus 3. And then if I were to multiply a over 2x minus 1 by these two functions right here, the 2x minus 1s would cancel. So I'm left with a times x minus 3. And likewise, if I multiply this fraction right here, b over x minus 3, the x minus 3s would cancel, and so you're left with a 2x minus 1. So let's figure out how to find what a and b are. So x is equal to 3. Well, if we make x equal to 3, this whole term is going to go away, and we're going to be left with b times 2 times 3, which is 6. 6 minus 1 is going to be 5. We plug in 3 over here. We're going to get 4 times 3 is 12. 12 plus 3 is 15. So we know that b is going to be equal to 3. So that's awesome. So we know that we can replace our b with the number 3. So we go ahead and replace b with the number 3. And then let's go ahead and look at a. So if a is equal to, well, let's first of all figure out what a is. So if x is equal to 1/2, then we know that the b is going to cancel, so we're going to look at 1/2 here. So 4 times 1/2 is 2. 2 plus 5 plus 3 is 5. If we go and do a, we're going to get a times 1/2 minus 3 is going to be negative 5/2. So a is going to be equal to negative 10 over 5. A is going to be equal to negative 2. So negative 2. So we can go ahead and make a equal to negative 2. And then we can start integrating this piece right here. Just like in the previous example, we can do negative 2. And I'm going to go ahead and pull out the constant for both of these. Might as well. Plus 3 integration of 1 over x minus 3 dx. So the reason why I chose this example for you guys is that this is what students mess up. So it's going to be u is going to be equal to 2x minus 1. You have to remember that you need to use u sub. So for this particular problem, we need to pull out a 1/2. And students always forget to do that. So be very, very careful for that particular part. So it's going to be negative 2 times 1/2. Because students always just jump to it, it's the natural log. So I've got the 1/2 out here with the negative 2, and now I can do the natural log of u for that particular part. If I make u equal to x minus 3, now this one's not going to matter so much because the derivative of u of x minus 3 is just going to be 1 dx. So I can just go ahead and do plus 3, the natural log of u, absolute value, plus c. And then finally, when we do the problem, finishes up, we're going to get negative natural log of the absolute value of our u, which is going to be 2x minus 1. And then 3 natural log of the absolute value of x minus 3 plus c. I don't imagine them ever doing this, but technically they can move the 3 up here, the negative 1 up here. I don't know why they would do that, but that is the correct answer. And just be really careful about, again, the fact that you must use u sub. So I think that's good for the first video. I will see you guys in the next video when we do the second method for partial decomposition.